Welcome. Hi, I'm your trainer, Mr. Ngigi. We are going to look at lesson 6, part 1, orthographic projection. We are going to look at the objectives, define terms, identify types of orthographic projections, illustrate orthographic projections, and discuss orthographic views. Orthographic, just like it employs the use of lines. So far we have looked at various application in CAD. So we are comfortable that we can use this, employ it in CAD. Orthographic projections is a system of drawing views on an object using perpendicular projectors from the object to the projection plane. Orthographic projections are collections of flat 2D drawings of the different sides of an object. Three planes of orthographic projections are frontal plane, plane on which the front is projected, horizontal plane, plane on which the top or bottom views are projected, profile plane on which the end views is projected. I'm going just to explain using that graphic. If you are keen, you can see that we are rotating it through an angle of 90 and also tilting it. So to get the front, we have that. So it's directly facing you. Then we have it's rotated. Then at the end of the day, we also rotate it again so that whatever we have is this. So orthographic views involves rotation. Depends on relative position of the object to the line of sight. It uses multiple views of the object from points of view rotated about the object center through an increment of 90 degrees. So types of orthographic projections. The two forms of orthographic projections used are first angle, this is the European style, and observers looks to the object and plane of objection or projection. Third angle, this is the American. The planes comes between the observer and the object and are imagined to be transparent so that object is seen through them. I can explain because this is for example, if I want to illustrate the first angle, so we have these planes or we have this quadrant. So this is the first quadrant, the second quadrant, the third quadrant, and the fourth. So using the first angle projection, so this is the view. The arrow shows that this is the front. Then the viewing is that you have, this is the top. And then under this, you can see another projection down here. That is what we call the plan. So in first angle, we have said that the observers look to the object and plane of objection. This is what happens. So if you have now the front, what happens is that it's seen as if it's at the back, is projected at the vertical plane. Then the plan, if you look at it from this end, is projected at the horizontal plane. This is what we call the horizontal plane. It's good we understand that for the first angle, if you are in the direction this, so the front will be on the other end, the other direction. And this an illustration is done and shown. For the third angle, you can see we are saying that the plane comes between the observer and the object and I imagine to be transparent so that object is seen through them. So this is what you have. So we are assuming that this one, we are imagining that this one is transparent. So whatever you see, it is transparent. So how do you see it? You don't see it from the back, but you see it from the front. So it's like you are seeing it in that direction. So if at all this is the front, that becomes the viewing. If you are viewing it from this end, then that becomes your front. So the front is where you see it, not at the back where you see it. Then you have the what you call the top. So the top is seen up here. So it's good we use we um, we get this concept kindly using this diagram because is a good illustration on first angle and third angle. So the symbols on engineering drawing, the projection angle is denoted by an international symbol consisting of a truncated cone, respectively for first angle. So this is how we see it. So you have a truncated cone, a cone that has been cut is called truncated. So this is the front, and then you have two circles. But these are not just circles. Remember, we have a circle, small circle, and a big circle. So it's like it's hollow. Then you have for that angle. So this is the shape that we have. Then arrangement of orthographic views. So for the first angle, you have the front, the end, and the plan, but it depends. So I've said like for our case, if the front was, we saw the front was, this is how the front is. So that arrangement is proper for this kind of viewing. So if the front is on this other direction, we have illustrated it that it is on the other end. So the front end and then the plan. So this is the arrangement for that scenario. So but if the front changes, then it will be front end and then the plan. So the plan is plan. So for the third angle arrangement, we have the front, the end, and then the plan. So that the much we can talk at the moment concerning the views. So we have an orthographic projection that we can use to illustrate the first angle projection. So you have the following. You have the service, which is the top. Then you have the front, and then you have the end. So in first angle, this is a good illustration. So we are viewing it from this end. So if you view it from the other end, automatically it comes to this. Remember what we said. The front, the end, then the plan. So we can see this view, B, and you can see A. So that forms our front. Then for the end, you have this view called the D, and you have the E. So that is the DE. So for the plan, it's clear. You can only see C. So that's how we illustrate it. And remember the spacing between this and that is 10, or manually and also in AutoCAD. So the following you can also produce it in AutoCAD. So I hope it's clear that in a nutshell, that we have two orthographic projections, the first angle and the third angle. And this is how the projections looks like. So it's good we understand it, that the front on this end turns to be at the back, but the front at this end, it's the same. It is at the front of the viewer, and that the plane is transparent. So that's the difference. That's the main difference. So the symbols are shown. Then you can have the arrangement of the views. But this one will do more practice. But you can also use it manually and also on CAD. So for your, so the resources that I used is the AutoCAD Basic, then Dr. Typhoon, orthographic projections. So if it's your first time, I would encourage you to subscribe. But if you have already subscribed, just like, share. I have some exercises. I explain two types of orthographic projection. Draw the symbols of the named orthographic projections. Then you can do the following. Produce it in first angle and third angle. And also employ rearing to enhance visibility. So thank you. I've been your trainer, Mr. Ngigi. Thank you very much, and you are blessed. Thank you.